Hello, this is Greg Allison with Galactic Gregs coming to you on the 26th of October on the heels of a major announcement by NASA that they found water. Yes, water has been discovered on the sunlit surface of the moon, hence the bright sunglasses, because it's a sunny day indeed at NASA and for space exploration. And they found it in the crater Clavius. Yes, the lunar crater Clavius, which is interesting to me as in that was in the movie 2001 A Space Odyssey, that's where the monolith was found. So that spurred space exploration. And indeed, findings in the crater Clavius may indeed spur space exploration. Maybe not to Jupiter or Saturn, to the moon. I paint this as in the novel from Arthur C. Clarke. But we're going to get all into how that was found and what it means, and how water might have got there, how water stayed there. But it just struck me really fancy because Frederick Wardway III was the science director for the movie 2001 A Space Odyssey, and he was a friend of mine. He was a person who lived here in Huntsville, Alabama, also in Washington, D.C., but he finally retired to Huntsville, Alabama. And this was this is a note that he wrote to me in this book where basically he says, to Greg, with warmest wishes and luck, and let's keep in touch. So, and that was from Frederick Wardway III. And I'll show you a picture of him real fast here. And he was the science director for the movie 2001. It's his job to bring realism, to make it look, like something that could be done. And so they actually did a lot of engineering into this. That's Frederick Wardway III as a young man back in the day when that movie was made, when I was just a little wee lad. Yeah, one of his best friends, Dave Christensen, was also a real good friend of mine, as was a lot of the German rocket team. So yeah, just had to put on some shades because it's on the sunlit part of the moon. And that is very significant because, my friends, we have detected already from the Lunar Reconnaissance Orbiter, and with suggestions previously from Clementine that there was water in the lunar polar regions and in those permanently shadowed craters. And that was a very significant find. But finding that there may be water distributed across the surface of the moon, or at least in certain specific locations, increases the likelihood more water. Greg, why is that important? The reason that's important is because water is not only the essential element for life, we have to have it. Our bodies are mostly water. You have to drink it. We need it to grow food. It's also a source for oxygen to breathe. And it's also constituents for rocket fuel. If you take water in hydrolysis, run through hydrolysis, you get oxygen and hydrogen, two the best components for rocket fuel. You want to probably liquefy them, put them in cryogenic state, but it's cold in those permanently cratered surfaces of the moon, so it might be easier done there than here on the surface of the Earth. So you've got rocket fuel, you've got means to grow food. Water is one of the heaviest things that we launch into space, and as you know, launch costs has been running somewhere around $10,000 a pound. Now, SpaceX is talking about with their Starship bringing that cost maybe to $9 a pound to low Earth orbit, but you got to launch two of them to get things out to the moon. So, that's just cost of fuel, by the way. So you're being about 18, 20, but more than that because they're going to add other costs into the system. So you might one day see costs go on the moon to $40 or $50 a pound, but still, if you can find water there and use the resources from it, no matter how cheap the launch services are from Earth, it makes sense to use the water there because it will definitely speed up the ability for us to settle, develop, and move out and explore space. So this is huge. It's very huge that on the moon we have found this. So let's get into this a little bit more. Before we do though, subscribe to my channel and bang the update notification bell and click all, because I'm going to do a lot more reports on breaking news like this. I will cover more stuff on SpaceX. I haven't done a whole lot of that of late, but they do have a lot of exciting things going on. I will be covering stories on NASA's Artemis program and its developments, and I have my own stuff that I am developing. Some of you may just saw my video. I talked about why it would be far easier to colonize Venus, and I'm not done with that because some of you are still questioning a lot of the aspects. I am working up the that's a 1 mile diameter sphere to float in the atmosphere of Venus. And some people, oh, Greg, that's just too hard. How are you going to get it there? And blah, 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 blah. What are you going to get it from? I'm going to cover that in future videos. And I'm going to talk about operating Starship in the Venetian atmosphere, how to land it in the atmosphere, refuel it, and launch it from the atmosphere of Venus. And it's going to be a lot easier than you can imagine. Oh, Greg, that's incredibly difficult. Hold on to your seatbelts, my friends. You're going to have fun with my future presentations on this topic. I got a lot more to cover on that. I can't even talk a lot about the history of things I've done in space, including launching balloons laden rockets called raccoons, and things I've done with the International Space Station. We're coming up on the 20th anniversary of continuously manning, personing the International Space Station, which I have done a lot of work on myself. And so there's just a lot of exciting things to talk about here. And I'm going to keep it going. I'm going to pick this pace up on this channel. I've had some tragedies this year that slowed me down, and I'm getting over that. So let's move on. Let's get back to our topic today. Oh, yeah, by the way, there are links below that you can support that. Click to support my channel through supporting my sister channel, Green Greg's. Green Greg's is a very different orientated channel, but you know, hey, I'm also into growing things, which will be very important once you get out to living in space. I'm working life support system components, you might say. Including closing the nitrogen loop with aquaponics. So I have quite a background in broad areas. My friends, so let's get back to this discovery in Clavius Crater. It was discovered by SOFIA. SOFIA is that airborne telescope that operates from a Boeing 747 that NASA's running, which gets above most of the atmosphere, which means it gets you don't have as much blockage, especially in the infrared spectrum, because there's not much water vapor that high up, you know, over 40,000 feet. And because of that, they were able to look at that 6 micron spectrum level where you can detect water. And you can't do this from ground-based observatories, and you needed some really good observation time to do that. Having that, they were able to detect water in places that we've never seen it before on the moon. And see, SOFIA offers a really good infrared telescope there, and that's what they were able to use to do this. So, you know, it's a lot better than what you might put in a satellite, or at least what we have so far. Now, I expect we're going to be putting a lot more emphasis on this moving forward. Greg, how in the world would water get on the moon, and how would it last, right? I mean, the moon is a harsh mistress, of course, but the moon, like Frederick Wardway III, were both members and board members of the L5 Society, later the National Space Society, which I was an active officer of, executive vice president for like 10 years. Even spent a tour as the chairman of the executive committee. So I've been the CEO of the National Space Society, my friends. Oh, by the way, the last president of the L5 Society, who come up with his own concept for power satellites and some really big launch vehicles, who also had a lot of Martian transfer concepts and did a lot of advanced space stuff, including did the proposal to Marshall Space Flight Center for Boeing Space Station work for what we call Work Package 1 for the HAL modules, who led that effort. Gordon Woodcock. Gordon Woodcock just passed away. And he was a good friend also. And he was the previous, before me, chair of the policy committee of the National Space Society, executive vice president. I replaced him in that position. And you might have seen, if you go back and look at some stuff that Jeff Faust posted years ago from an ISDC called the Great Space Debate. It was me and Rick Tummelson and Bob Zubrin debating each other on the panel. And a lot of what I got, you know, a lot of position I was debating from was based on Gordon Woodcock's inputs. You know, I was actually debating against heavy lift launch vehicles, which is not really where I was at, but you know, hey, had fun with it. So all this back to it. Let's talk. How did it get there? How better yet, how in the world would you have water in the sunlit, hot vacuum of the moon on just the regular surface area where the sun's shining? You know, the moon gets up to 250 degrees Fahrenheit in the course of that 14 Earth day long lunar day. It gets extremely hot, like an oven almost, and it's in a vacuum, water will not stay, it will not remain. Water will sublime away. And of course, it'll boil away in heat like that. But even in cold, water will just sublime away. If you the ice will, and have you ever had ice in a refrigerator for a long time and notice it just dwindling out? I've had ice cubes in my refrigerator, so they just dwindle down. This sublimation, it just evaporates off the surface. Yes, even ice can evaporate if the atmosphere around it is arid enough. So, of course, water would do so more so. Do so more so. So, in space, water is in a vacuum. You can't have liquid water. It just won't exist in a vacuum, at least not for long. We've detected traces on Mars where some ice may have melted, or there might have been a run from subsurface water into down a crater wall. And my friends, that water either got reabsorbed or evaporated into the Martian atmosphere, and then it would be gone in no time because there's like no atmosphere on Mars. So, Greg, Mars has an atmosphere. Yeah, it does, but it's not 1% of the atmosphere on Earth. It's like the atmosphere at 100,000 feet on Earth. Yes, at 100,000 feet on Earth, we have a Martian atmosphere. 1%, except they don't have as much CO2. So it's very much like where I used to fly my balloons to at 100,000 feet. And I've gone above that and operated below that too. Well, I've operated in the 75 to 115,000 foot range of the balloon flights that I've conducted in the past, which have been quite a few. All right. And, doing research for rocket launches and then actually conducting the rocket launches. Dozens of balloon flights. So all that said, water does not like a vacuum. It cannot exist in a liquid state and will not exist even in a solid state very long unless it's in a comet or something that's covered. Usually when you get these comets or dirty snowballs, it's the other stuff crusting over that protects the water. And similarly on Moon, you needed something if you're to protect that water so it will stay there. The water in the cratered regions is probably covered with dust, just like on a comet. The water that is located on the Moon will be, ice is more stable than liquid water, by the way, but in the heat of the Moon, where you get that hot, well, they believe they don't have evidence, but they believe, and it's something that really makes much sense, that water is locked up in the glass beads you find on the lunar surface. Now, is it actually glass beads are just covering the water, kind of like dust on the Moon at that heat? Not very likely. It's probably like trapped in a bottle. That glass bead has water dispersed in it, and it's kind of like a bottle. That water can't get out because it's held and contained inside the glass. So, well, Greg, how would it get there? Well, there's two methods proposed to that. One of them is the solar wind just sends out all these hydrogen particles, and glass is silicon dioxide, which means it has silicon and 2 atoms of oxygen. So it could be that there's also thought to have hydroxyl, hydrogen and oxygen located in it. So it could be that the solar wind comes in and impacts the glass beads and deposits hydrogen, and in some fashion it reacts due to the energies of the impact of the solar wind, or from the energies of micrometeoroid impacts, or just the heat inside. Somehow it reacts, and either with a silicon dioxide or hydroxyls, and forms water. They're finding water. In fact, the amount of water is equivalent to about a 12-ounce bottle of water and a cubic meter of lunar regolith, which is the top surface. It's called regolith. Lith means rock, because what you've got is finely powdered, beat up soil from all the impacts and micrometeoroid impacts on the Moon. So they call it regolith, not soil. Soil invokes the idea of having organics, which they don't have there on the Moon. It's just beat up rock, basically, rock pulverized. And I've seen the lunar samples they brought back, and it's full of these glass beads, and it's beautiful to look at. You to take a piece and hold it up against a window or a light, and see all those little glass beads in there, especially if you can look at it under a magnifying glass or a microscope. It's beautiful. It is stunning to see, and I've seen it. It's not like what you walk out here and scoop up. It's not like what you find in sand. It is totally beautiful, but it's also a hazard in that it is glass, it is shattered, and it's broken up. It's got all these little shards in it. If you breathe it in, it can mess you up in your lungs. It can jam up equipment, rotary joints. They had problems with the spacesuits and Apollo missions, with putting the suits on and off because it was starting to get jammed up with this stuff. And it smelled like smoke or gunpowder inside the lunar excursion module ascent stage where the astronauts stayed during the Apollo program. And that was principally why. So you've got to have means to control this stuff when you're on the moon, or you're going to have some real health problems and equipment operational problems very soon. All right, that's not the topic. The glass bead subject kind of got me there. Now, the at a 12-ounce bottle per meter, you're saying, Greg, that's not much. Yeah, it's less than you'll find in Sahara Desert. But when you consider the lift cost to get to the moon, the price of being there and operating there, the value of water is significant in space, especially that far out. So it may be worth processing if we can find the ways to unlock it. It might be that you run it through a heat process and liberate it. That may be one way to do it. You may be liberating water through the process of mining for helium-3, for example. That may give us an extra impetus to go mine helium-3. So we got two reasons to mine the regolith. Also, there's a lot of titanium in lunar regolith. There's a lot of aluminum. There's iron, and just distributed throughout the regolith, and of course oxygen, hydroxyl. And so there are elements that we can, if we start mining this stuff and processing it, you could indeed make a lot of useful materials to come out of that. And of course, the silicon dioxide lends itself to making glass, which is what we find all over the moon. Glass is there naturally, which is good for making fiberglass, which is a good construction material. Bing. A lot of things can come from lunar regolith. So we just have another reason to go mine some of it. Greg, we don't want to mine the moon. We've messed up the Earth. Well, I'll tell you what, the moon gets crushed and beaten, pulverized by meteorites and micrometeorites all the time. The moon is cratered and craters on craters on craters, big and large. There's nothing living there. So we're not going to be messing up any biosphere. We may be creating a biosphere from having done this. And I scantly, it would take an enormous amount of process to make anything you could see from the Earth. So I don't think there's anything we're going to notice from Earth for a very, very long time from any process from lunar regolith on the surface of the moon. Essentially, what you're doing is you just got some crawler going over digging and going back over. So the shape of the craters would be roughly the same and everything. They're just going to be scooping up regolith right off the top and dumping it right back out after overheating or heating it or something like that. Most likely. The tellings, that the miner will be the process. And that's what some of the artists and engineers envision. Who knows? We're not there yet, but we're a long way from having anything to be concerned with. So, but Greg, we got so much water in the lunar polar regions, why go mine this stuff? Well, that's a good question, and we may not. It might be easier to extract the stuff from the lunar polar regions. But see, one thing I've been worried about is lunar polar regions seem to have a good bit of water, but over time that is a limited amount. And it may be good to jumpstart a major space development and settlement program. How long will it sustain it? Maybe it will sustain the point that you can bring in water from comets and other sources, water-bearing asteroids, and so forth, or have a far cheaper launch cost from Earth and ways to get up there. So there are a lot of potentials for what that means. But the coolest thing about it is that we now know that the water, a meter, 12 ounces per meter of surface may not sound like much, but integrated across the entire lunar surface, that is a lot of water. So even if you go to the lunar polar regions first to mine water, then you got a lot of backup water for fuel, for breathing, for drinking. I did a paper back in, I think, 2008, and I was calling for a water economy for space development. So just a draft white paper I wrote way back then. I distributed it pretty widely, by the way. So this is exciting. This may there's even thoughts that we might one day send fuel from the moon back to low Earth orbit. So say starships refueling in low Earth orbit, you've probably seen the scenarios of two of them back to back, tanker refueling. Well, it might be that you're actually just refueling from water from the moon. It might be cheaper to bring it down to Leo than to bring it up from Earth, even with a low operating cost of a starship, which may further reduce the cost of going out into deep space, be it Mars, which is the color of my shirt, or Venus, which I've been of late promoting going to first. So whether we're going to Mars or going to Venus, it may make it a lot more tractable cost-wise. So, or of course, we're probably going to the moon first, and that's okay. But I don't see the moon as a place for long-term human settlements of only 1/6 gravity. Maybe I'm wrong. You know, Selenians will be some tall, skinny people with only 1/6 gravity. They probably would never want to come back to Earth. I don't know how. If you grew up and evolved in an environment 1/6 gravity, forget it. You're not going to want to walk around Earth, I don't think, unless you got some kind of assistive devices. Okay, exoskeleton suits. There's a good science fiction movie. Invasion of the Selenians. Okay, I digress. I have a little fun, guys. We don't have to be serious all the time, even if you're from Sirius. The star, of course. No, I'm from Earth, at least in this lifetime. So, pardon me. The thing is that we've got a rover going to the polar regions of Mars, and it's called Viper, Volatile Investigating Polar Exploration Rover. And it's going to have an experiment on it. It's a drill, and it's called Prime 1. And they think Prime 1 will help us look for water along this line. So they're also planning to go into the sunlit areas, fully sunlit, partially sunlit, and fully shaded areas of the moon. Well, Greg, what's so hard about operating in the craters? Well, to get to the inner polar energy regions takes more delta V than just going straight for where we landed back in Apollo days. And I'll kind of show you that. This is a little moon globe I got when I was a kid, and it shows well, you can see this was an old one. In fact, this only has 2 Apollo landing sites on it. Indeed, when I got this, we had only landed at 2 spots on the moon. This is Apollo 11 and Apollo 12. And if you notice, these landing sites are right along the lunar equator. And this used to fit in a little thing that spun, it was kind of cool. And I've had this since the 1960s. I don't know, I might have got it. Well, yeah, I might have got it in 70, but it was right after Apollo 12, before they had a chance to make anything for Apollo 14, the next landing mission. So that was my little moon globe, my first one. I've been interested in space and space exploration since I was a kid. Apollo 7 got me hooked. I mean, I was seeing the Mercury. I vaguely recall the Mercury missions. And of course, Gemini, I laid with my brothers on top of a smokehouse and watched the Echo satellite go over. So space has always been an interest to me, but I got bit when I discovered what they had to do with Apollo 7 to overcome the Apollo 1 fire and just the wonders of living and working in space, like, what anti-gravity meant. And I was only 7-year-old. That's when I saw a special from NASA, and it really hooked me. Okay, so let's get back to this. I had Major Matt Mason toys too. And the book. And one of those books that talk about a big lunar worm. You know what I do these days? I have a worm farm as a side business. Yeah. All right. How'd say how all that impacted me? Okay, I digress, but I like to have a little fun. So bear with me here. Let's get back to the serious aspect of this. The lunar finds, which is the Regolith, are so significant that it really offers the chance to propel our civilization to space development on a much faster time scale. The problem with operating in the, it's been said, including my Vice President Pence has said, we're going to land a man and a woman in the lunar South Pole in 2024. That's just 4 years from now, my friends. That is a very significant place to operate in and out of, because once you're in the shadowed region, you have no line of sight communication to Earth. Maybe we'll get some Starlink satellites going around the moon, right? Maybe that'll be our Wi-Fi communications in some point in the future. But in the meantime, we don't have a direct communication path to Earth. So there's the danger of something happening down in there. You don't have support from mission control. There's also, like I said, the added cost of getting to those polar regions because there's more delta V involved. And it's cold, so you got the challenges of operating in the cold. And while you're down in the crater, unless you have some solar panels on those permanently lit mountains that have sunlight available to them almost 24/7 in the polar areas. If you're down inside a crater, you don't have the luxury of sunlight to power your systems. But right nearby, and one of the reasons to go to the lunar poles is, if you're rotating, some of these poles, see, the moon don't have a lot of tilt like Earth, and it don't have any tilt. So it's like Mars only has 3%, Venus only has 3% tilt. But up here in these lunar mountain areas, crater rims, you got areas that are in sunlight 24/7. You might have to rotate your array once every 28 days to stay up with the sun. But that's not a big deal. That's a pretty slow rotation rate, like the moon, which is phase locked with one face always facing the Earth. Oh, there's not a dark side of the moon. There's a far side of the moon, my friends. It's daylight. Every surface on the moon, except these permanently shadowed craters, get sunlight for 14 straight Earth days. But the far side is different than the near side. The near side is denser, and that's why it's phase locked into Earth. Those dense basalts that weld up after some ginormous impacts there. But the far side has higher mountains and different terrain, and it's a different surface, a very interesting surface. We've not explored that, except the Chinese landed there. So yeah, they got some interesting reasons. So we need to be on the way to the moon. We need to get back up there. It is a strategic high ground. We do not want to be left behind by China and other places who represent systems that's not as democratic as ours, and who may deny us access. There are ways that once you get the high ground, you could deny with a mass driver that could continuously shoot out stuff that you might be able to put little directional packages on. It might be like a machine gun fire that could not deny you access to even launching into space. Oh yeah. So, or, big packets coming out of a mass driver with some directional system on it, maybe a little propulsion. Could be an enormous weapon of mass destruction. You could take out a country with something like that. If you could build little propulsion vehicles to be with using lunar fuel to be launched from a mass driver and direct them toward Earth, coming in with a kinetic velocity of 25,000 miles per hour, with some carbon or some of the silicon. Oh yeah, or some of our first heat shields were using sand, basically, silicon dioxide, which is plentiful on the moon. Plentiful, as long as you want, it can make it an ablative surface. You could get something the size of a telephone pole through the Earth's atmosphere with only 3% ablation. If you have on the very tip end, if it's got a 20-to-1 aspect ratio, like a telephone pole, it would just be basically eroding the end on it and just cap that with silicon dioxide, and you got an enormous kinetic energy weapon, no matter what mass is in it. Anything. Of course, there's the rods of God, the tungsten rods that some people were talking about firing down from Earth orbit satellites to the ground. So, my friends, yeah, we don't want to let one country, it may not be our best friend in the world, have exclusive access to the moon. That's maybe a good reason to have a space force. All right. So what we have now is extra reason to get to the moon. One is now going to make space exploration more affordable. And two, we can't afford for somebody else to have sole access to the moon. We just cannot afford it. It's not something that we can support or afford. Now, you can find more stuff on this announcement at nasa.gov/SOFIA, and I will put the link below to that. The concentrations now in terms of parts per million are on the order of 100 to 412 parts per million. So we're going to ask another big question here before we're done. So that's the other big question. Let me just get into it. Why didn't we discover this when the stuff we brought back from the Apollo missions. Now, it could be this. Clavius Crater is not on the equator of the moon, so it may not be heat quite as much, or there may be some other dynamics involved. Yeah, we haven't talked about how it got there either. Well, we talked about one method. There's another method. Clavius Crater might have some unique attribute. Maybe there was some comet that shattered and rained in rich micrometeoroids, because another way that this stuff could have got there is micrometeoroid impacts. And micrometeoroids might have been water-bearing micrometeoroids. This can happen, especially if they're the bits and pieces of comets or water-bearing asteroids. And so a lot of micrometeoroids may have water in them. And so when the impact on the moon, two things could happen. Either they cause reactions of the existing hydroxyl atoms in the lunar fines and cause them to react through the heating process and create water, or they're actually depositing water, which and then when the glass is reforming in that water vapor, it captures it and settles down. So of course, most of it would be lost, but you get enough that's happening over time, you might get a fair bit of water in the surface of the moon. And it could also be buried a lot deeper as the regolith gets churned over time. Yeah, the moon surface gets churned over. And you might find this stuff several meters down, maybe down to 6 meters deep. The moon is not stable on its surface, like I mentioned, because of micrometeoroid impacts. So that is something to consider, and it impacts larger stuff too. So it might have been something hidden there that gave Clavius Crater an interesting anomaly. The monolith, 2001. So that's another method that the water could have got into the glass. And that might possibly, if it's more connected to comet impacts, mean it's more distributed in spots and maybe not universally as they were suggesting in the announcement today. That would explain why that and perhaps just equatorial locations, or maybe they just didn't break open the glass beads and look inside them. Maybe they didn't put the IR instrument straight on the glass beads because they never thought about it. Now, that's probably the real answer, because often we have our prejudices, and because we have a prejudice about something, we don't even think about it. Our world, we have a worldview, and our worldviews, we automatically assume what is and what isn't possible. And when we have a worldview, you take in all the other data and information around you according to the worldview you already have. People have a prejudice, a bias that is a filter. Their worldview becomes a filter to assimilate more information. We assimilate information in such a way that it reinforces the worldview we already hold. And that has been referred to as you're having rose-colored glasses. It is the rose-colored glasses through which you interpret the world around you. This was a lesson taught to me by Sergeant Spivey at Fort Richardson, Alaska, when I was attending primary leadership school. Great instructor. And because a lot of people in the space community have these worldviews, it might have been that no one just even thought to look at a glass bead to see if it had water in it. Now, I think that is the answer why we don't know. And let's hope it is, because if that is the answer, this stuff is distributed all around the moon. If it's not the answer, then Clavius Crater suddenly starts getting a lot more interesting. Maybe there is a monolith there. Oh, by the way, Clavius Crater is located just south of the rays of Tycho. And, but it may be these rose-colored glasses. Another reason we have these glasses, because I knew I was going to come around to this. Not only is going to talk about bright sunny sun, but that is why people think this isn't possible too, or why they think we can't operate a starship in the atmosphere of Venus. Well, my friends, if you watch this presentation, my previous presentation on this, that gives you the answers. Why, if you haven't watched it, watch it. Get beyond the first few minutes of me being funny, because I like to cut up and have a little fun. But go into it and listen to what I'm saying. Also go into and be prepared to watch my follow-ons, where I'm talking about how you're actually operate a starship in the atmosphere of Venus and how you can use it as a construction back to do other interesting things, including this concept. I call this the Allison Sphere Venus 5, ASV 5. I'll be talking about ASV1 and or ASV2 in my next presentation, in conjunction with operations of Starship in the Venusian atmosphere. And I will do other follow-ons probably about Starship operation in Venetian atmosphere. I have quite a few videos I'm planning to do on Venus, on SpaceX, on Starships, on Artemis, on what we call the Space Launch System, which I know a little bit about. And space station, other developments we're going to do. I'm not going to focus on some channels, or there's some good channels out there that just focus on SpaceX or just Starship. And yeah, there's a lot going on there, and that's a hot topic. It's one of the hottest topics there is. I don't blame them. I'm going to be a little broader there. I'll talk about life in space. I'll talk about new findings and planets and things like that. I have a broad spectrum of interest, but I will cover those things too, and I'll try to bring you more. So, ladies and gentlemen, at this point, I'm going to say, hang on to your seatbelt. We got some interesting times coming in space development, space exploration. I plan to bring you more and more of it. And with that, I'm going to say thank you, my friends, for watching. Have an awesome day.